This is going to be the last module for this course for quite a while, so I thought it fitting to give you some info on how you might build a workstation intended to grade different kinds of projects. This module is focused on building a Windows workstation, as I've always worked in Windows, and I've never really used Macs in any professional capacity. The reason for this is that I always need easy access to the innards of my machine to make updates to components and to install some irregular components such as DECLink, RAID control or HBA adapter cards. The new Mac Pros made this more difficult, and also Apple threw its lot in with AMD, and I've always had a very strong preference for NVIDIA and Intel components for this kind of work. A workstation is made up of a number of different components and also requires an external reference monitor and possibly a control panel. We're going to break the task of building a workstation down into chunks, talking about the importance of different components and the impacts they have. I'm doing this because as you finish each section, you can make a note of the components you will want for your own workstation. The idea is that you build a list of things you need and end up with your workstation list by the end of the module. So, if you want to build a workstation from scratch, and remember, buying a ready-built rig, which is also referred to as a turnkey workstation, is always an option. A brief mention for laptops and turnkeys. Different companies sell fully constructed workstations, and it's down to you to find a local supplier, but it's also possible to turn around web work on a laptop. In this case, manufacturers like Apple, Dell and Razer are all excellent choices. Keep an eye on the graphics card and make sure it's up to the task. In laptops, a GTX 1070 is a good fit for 1080 web video. So, without further ado, let's take a look at all the components we're going to need if we're going to build our own custom-built workstation. Click on through to the next lecture once you're ready. In this lecture, we're going to look at the processor or CPU, which is also referred to as a core, for our workstation, and what might drive us to buy any particular CPU. Now, we're looking at this first because the CPU can actually dictate how much graphics card performance we might get out of our system. That sounds odd at first, and I'm sure plenty of you, gamers in particular, think that that's wrong, but we need to talk about something called laneage. We have a number of PCIe slots in our motherboards. These slots allow us to install PCIe components like graphics cards, DECLink cards, PCIe drives and RAID control cards. But there's a limit to what PCI components can be supported at full capacity in our system, and that limit is dictated by the number of PCIe lanes supported by your CPU. This is essentially a resource that dictates how much data can be sent to and from different components at lower latencies. This is really important, especially when we are building multiple graphics card rigs, as a card that doesn't have enough lanes does not function at full capacity. We need to look at how many lanes our system needs to run at full capacity, otherwise we're just not going to be getting the performance out of the components that we're paying for. Graphics cards can run on 16, 8 or 4 lanes of PCIe support, and their capacity is reduced the fewer lanes they get, with 16 being full and 4 being the minimum. That means that for a single GPU system, we should ideally be looking at a GPU that offers at least 16 lanes of PCIe support, possibly 28 or more if we also want to use an external reference monitor or some other PCIe components. Now, in a lot of applications, the difference between 8 and 16 PCIe lanes on a graphics card is not that pronounced, but in Resolve, it can make a higher difference at higher resolutions. For 1080 work, you might not need to worry too much about this, but 4K and up, you really should be keeping this in mind. So, good cores for 1080 single graphics card workstations that do not need an external monitor would be the i7 8700K, the i5 8600K, or the i7 9700K. All of these provide 16 lanes of support and thus will support a single PCIe component at full capacity or a graphics card at full capacity. If you just have the one graphics card and are working on web video, then one of these should do you fine. If you require an external reference monitor, then you will need additional lanes for a component called a DECLink or breakout card. These slot into PCIe slots on your motherboard and send a video signal out to your external reference monitor. These cards typically take 4 lanes. For 1080 work, you can get away with a powerful graphics card on 8 lanes and the DECLink on 4. Anything bigger and you should consider a better core. A good core that supports 28 lanes of PCIe is the i7 7820X. With the extra lanes that provides, you might also consider a RAID control card as well. Finally, we have 44-lane cores, and these are for full-blown multi-GPU workstations that have 2 cards on 16 lanes each, plus a DECLink and also a RAID control card. These are the highest-end components that a freelance user might consider using before moving on into server setups and multiple processor workstations that you might find in large facilities. These are super expensive, and good examples would be the i9-9960X, the i9-7900X, or the i7-9800X. Now, there is unfortunately one more thing we have to remember when building a multiple graphics card workstation, and it's to do with the motherboard. Not every single PCIe slot in your motherboard will support 16 lanes. This means that if you're not careful, you can install a card into a PCIe slot which is limited to 8 lanes, and at that point it does not matter what your core is. The card is only going to get 8 lanes. So what we need to do is we need to look at our choice of motherboard and see that we have enough accessible PCIe slots running on 16 lanes in order to support a multiple graphics card workstation. There's a lot to remember in doing this, I know. Now, laneage isn't the be-all and end-all of this. The core does have performance implications beyond enabling what the GPU does, but most of our performance is decided by the graphics card or GPU. It's a matter of balancing the two components out. Mainly, if you need multiple graphics cards, then you have to get a core that enables that. Now, this has been a good overview of CPUs and their role in building a Resolve workstation. Next, we'll be talking about graphics cards. Click on through to the next lecture once you are ready. Okay, let's talk about one of the determining factors of performance during the grade, the graphics card. For the rest of this course, I'm going to be using the term GPU, which is a contraction of Graphics Processing Unit, to refer to graphics cards. And one further thing to note, we do not use SLI or Crossfire in Resolve workstations. We're going to be referring to our notes on the CPU during this. Remember that the CPU laneage dictates how many devices we can have running at full capacity in our system. When building machines with multiple GPUs, especially if we're using certain kinds of graphics cards, we need to keep a close eye on the available lanes. Now, it's usually the CPU that decides the overall performance in post-production. It has a huge impact on processing footage and also in a lot of OFX plugins as well. So why does Resolve rely so heavily on GPU performance during the grade? Two things. First, it's down to what we call CUDA, a parallel computing platform designed by NVIDIA that helps GPUs speed up certain operations by processing them in parallel. DaVinci Resolve's grade performance is more reliant on the CUDA performance of your GPU than anything else. The AMD equivalent of this is OpenCL. And secondly, we have VRAM. This is the RAM memory of your video card, and this is important. Larger amounts of VRAM are required for higher resolution projects. If this fills up, you can get a screen full of corrupted noise and a warning telling you that your VRAM is full. The only way you can get around this is to get a better GPU or to work with lower resolution media. This means that as long as you have the PCIe lanes required to run all of your chosen cards at full capacity, your graphics card will make the largest perceptible difference to your grading performance. First, we'll talk about 1080 HD projects. For HD projects, you won't need multiple GPUs in your build. A decent enough card by itself should suffice. All of the more recent NVIDIA GeForce cards have a decent enough CUDA performance. You can get by for HD work on something like a GTX 1070 or an RTX 2070. These cards will only slow down when working with 1080 footage once you begin to use intensive operations such as blur, noise reduction, or many stacking secondary keys. Once you hit that point, you can then rely on the render cache in Resolve in order to smooth out any slow patches for playback and review. If you want to have fewer slowdowns, then you can look at either a single GTX 1080 or 1080 Ti or an RTX 2080. These are very powerful cards, and if you're not doing a lot of intensive work like noise reduction, then it might not be prudent to spend so much on them. A single GPU build containing an RTX 2070 would be ideal for most web video purposes unless you want to go into very heavy VFX. Alternatively, if you want a cost-effective solution for 1080 work, then an AMD Radeon RX Vega 64OC model is also a good choice. However, there are currently issues with corruption when working with AMD cards and Blackmagic RAW footage. No matter what you choose for your workstation, 1080 work requires a minimum of 4 GB of VRAM on your card to ensure reliable playback. As we're talking about single GPU here, you're going to want a core with between 16 to 28 PCIe lanes, a full 16 for the card and a few more in case you want any other PCIe components, such as DeckLink cards or RAID controllers. Okay, so let's start talking about 4K builds. We can make do with a single card for grading 4K, and that card is either a GTX 1080 Ti or, and this is a lot better, the RTX 2080 Ti 11GB model. This will allow you to work with 4K footage with reasonably good performance. It will fall below real-time playback very quickly when using noise reduction, so do watch out for that. I would recommend an RTX 2080 8GB or a Radeon Vega 64OC 8GB model as the minimum when working with 4K material in Resolve. Next, multiple GPU builds for Resolve. Now for real performance, we have to use multiple GPUs, and this can be quite difficult to do in systems built from consumer-end components. First, only Resolve Studio can use more than one graphics card. The free version is locked to a single card. If you don't have a paid license for Resolve, then you will get nothing out of installing a second card. If you're running a license of Resolve Studio, then we'll go over multi-GPU builds. The big thing here is to make sure that you have a core that provides enough PCIe laneage for any cards you're using. If you don't have enough PCIe lanes, then your cards will not run at full power, and that will mean you're not getting the performance you're paying for. We'll take a look at 2 card builds in this lecture because 3+ requires machines with multiple CPUs, and that's only really viable for large facilities. Now, when talking about multiple GPUs, there's another very important thing that we need to remember. Every graphics card we use in our workstation needs to be from the same manufacturer. That means every card in your system must be either NVIDIA or AMD. You cannot mix the two. That is super important. And when building multiple GPU workstations, it really is for the best if every single card in that workstation is also the same model. That's very important. Don't mix 4GB with 8GB cards. Do not mix AMD with NVIDIA, all of that stuff. Okay? First, Resolve will not double its performance if you add a second card. As is usually the way with stacking up anything in computers, there are diminishing returns. And also a word on VRAM. There's a minimum of 8GB of VRAM for 4K work, and it is important to note that every card in your rig must reach this minimum. VRAM does not add together. Don't think 2 4GB cards will let you work in 4K in real time. Each card essentially needs its own copy of what is going on, and this occupies the VRAM, so both cards need the minimum capacity here, which is to say you should look for 2 cards both with 8GB of VRAM. That is very important. With the 8GB target for VRAM, we're really looking at a small selection of eligible cards. 2 Radeon RX Vega 64OC models may work, but it's difficult to get these into a consumer case due to their cooling systems. The best bet in systems like this is to look for a GTX 1080 or 1080 Ti, or an RTX 2080 or an RTX 2080 Ti. Putting 2 of the same card together will get you excellent 4K performance, and you will only notice significant slowdown when using CPU-heavy operations associated with some RAW formats and OFX plugins. Even then, it should be relatively quick to set up the render cache to sidestep any slowing down. You really need to look at a CPU with at least 44 lanes for a system like this, because you are definitely looking at a Decklink card if you shelled out for 4K performance. As always, you need to look at the power consumption figures for your machine and make sure that you have a power supply unit that can match their maximum draw to ensure that everything runs at its proper speed. So, this has been a good overview of what GPUs might fit what kind of workstation. Next, we're going to talk about storage and RAID. So click on through to the next lecture once you're ready. On to motherboards. We didn't start with the motherboard because that dictates all kinds of things like which socket type of processor you can use, how many graphics cards you can install, etc. So I find it easier to choose the motherboard once we have an idea of the core and the GPU we want to use. The main thing is we need to look at what kind of processor is supported by that motherboard. There are many different kinds of socket types for processors, such as LGA 2066 and LGA 1151. You need to match up the socket type to the processor, otherwise the processor will not physically fit into the motherboard. You need to match the letters and the numbers here. That is very important. Now, the motherboard we want varies depending on the kind of workstation we want. So let's take a look at a single GPU system for 1080 work. This kind of build is meant for web video and does not use an external reference monitor and only needs a single GPU. That means we don't need a motherboard that will support something super high-end like the i9. We can get away with a motherboard that supports mid-range consumer CPUs such as the i7 8700K, and that core matches the LGA 1151 socket. Motherboards for this kind of setup are mostly gaming components, and most of the multiple PCIe slot, and you should look for 4-slot versions, of the motherboards will do here. For high-end single GPU with an external reference monitor, we are going to want a 28-lane core. The higher-end cores tend not to use the LGA 1151 sockets. Most cores, and you must always check this for yourself, that support more than 16 lanes tend to use the LGA 2066 sockets, so you'll need a motherboard with one of those. There are gaming motherboards that support these sockets, though they are more expensive, and a good example is the Asus ROG Rampage 6 Extreme Omega, I love gaming, and a more cost-effective choice might be the Asus Prime X299-A, which is roughly half the price at the time of this recording. These boards also fit most of the 44-lane cores like the i9-9800X as well, making them a fit for a rig with multiple GPUs for 4K work. But remember, you must always check the socket type of your motherboard and CPU when building a workstation. With core compatibility out of the way, another feature to look for is an integrated RAID controller. But once we have a board that matches our core, most of the mid to high-end gaming boards will do fine. Then it's just a matter of assembling everything together. So this has been a good overview of choosing which motherboard we want for our workstation. We're now going to move on to external components, and then we are nearly done. Click on through to the next lecture once you're ready. Okay, we've covered almost everything else, so it's time to talk about storage. This is the last internal component we're going to discuss before a quick overview of control surfaces and monitors. Storage refers to your hard drives, both internal and external. For 1080 work, our storage is not super important, it's unlikely to cost us any performance. 4K and up, however, is a different story. First, we're going to talk about the two main kinds of hard drive. First is spin disk, and this is the standard hard drive. It has a disk, a needle, and typically a relatively large storage capacity at a relatively low cost. These make for excellent long-term storage solutions, because you can get large amounts of storage space relatively cheaply. I run two 3 terabyte disks in an external RAID enclosure and another 3 terabyte disk inside my machine itself. And let me tell you that 9 terabytes is usually not enough, so I'm in the process of expanding this further. Whilst large capacity for low money may sound great, there's a catch. Hard drives have a read and a write speed. This dictates how quickly information can be written to the disk or accessed from it. If our drive is too slow, then it will prevent us from playing back high-resolution media at real time. For 1080, this is not much of an issue, but for 4K work, or working with 4K source, and especially some RAW formats, this does become a problem. It doesn't matter how good your GPUs are, if your drive is too slow to read the 4K, 6K, or 8K footage, you'll still get slow performance. And this brings us to the next kind of drive. SSD drives. Solid-state drives are extremely fast and have lower than average storage capacities and are considerably more expensive than spin disk drives. Because of this, SSD drives are the best choice for what we call our workspace. Drives that house material we are currently working on in our Resolve projects. Resolve needs to read information from the drives constantly, and when working with 4K and up, the read speed becomes extremely important. Now, one thing to keep in mind about SSD drives is that the more they fill up, the more they slow down. If you fill an SSD drive beyond 70% of its maximum capacity, then you will start to see a sharply declining read-write access speed. Now, this gives us a few problems. A, we need a surplus of storage space, and B, the read-write access of a single SSD is not enough for 4K RAW or higher. We actually need more space and a fast speed. But how do we do this? The typical high-capacity, high-storage speed solution is what we call a RAID. This allows multiple hard drives to work in parallel and thereby greatly speed up the tasks they are assigned to. Now, for 1080 work, a RAID should not be necessary unless you are routinely delivered large image sequences to work on. RAID is the domain of those of us who routinely work on 4K RAW formats. There are a few different kinds of RAID, and we'll discuss the two most relevant. RAID 0. RAID 0 basically allows us to stick several identical drives together and have them function as one larger drive. It has a minimum of 2 drives. It allows us to combine storage capacity and read-write speed with diminishing returns. It is not just like doubling performance with 2 drives, but the increase is very significant. I use a RAID 0 workspace consisting of 3 SSD drives for my 4K projects. I would recommend that you make workspace RAIDs from SSD drives, as you will struggle to get what you need out of a collection of spin disk drives. Now, there's one more thing to keep in mind regarding RAID 0, and that's that it's not a safe storage space in the long term. The thing about RAID 0 is that a single file is usually spread across all the drives in the RAID. That means if one drive in the RAID array fails for whatever reason, you will lose everything in the whole RAID even if the other drives are fine. Because of this, you should move your projects onto your workspace, finish your project, and then when you're done, remove those files as soon as you no longer need them. You will want to regularly wipe and defragment a RAID 0 array, and you should never leave important stuff hanging around in there. For secure storage, we have to rely on either another form of RAID, which we will cover in a second, or, and this is much easier, backing everything up onto external hard drives in case of hardware failure. RAID 5. RAID 5 has a similar level of performance to RAID 0 and has the added benefit of providing redundancy. This means that if a drive in the array fails, we don't lose everything, as that data can be reconstructed through what are essentially backups stored on each drive. RAID 5 requires a minimum of 3 drives and is typically used with 5. This makes it impractical and cost prohibitive for a lot of freelancers and independent practitioners. Most mid and high-end motherboards will have a built-in RAID controller that will allow you to use at least RAID 0, which in combination with external backups is what I recommend. I would recommend you look at a RAID 0 array with 2 SSD drives, each with a capacity of 500 GB or 1 TB each. Complement this with at least 2 TB of storage on a standard spin disk drive, and you should be okay for web video work, though you will find yourself amassing external drives quite quickly. You can also get hardware RAID control cards that slot into PCIe slots on the motherboard. These vary enormously, and you need to check what levels of RAID are supported before you buy one. For the most part, I get along fine using the integrated RAID controller on my motherboard, but be sure to check your motherboard before you commit to buying a load of drives. So, this has been a good overview of storage media for workstations. Next, we're going to start talking about external components, reference monitors and control surfaces. Click on through to the next lecture once you're ready. Now, I'm sure it's no surprise to hear that your monitor is a big deal in color grading. There are a few issues to cover here, so let's break it down step by step. First, we can grade in 2 ways. With a good GUI monitor if we're working for web, and with an external reference monitor if we're working for broadcast or cinema. We're going to talk about the GUI monitor setup in this lecture. Let's say we're grading for web video and have a single GPU setup with 16 lanes on our core. We can use an external monitor, but in order to do that, we have to move some laneage over to a Decklink card. Now, at 1080, this may not have too much of an effect, and if you really want to go for high-end web content, this kind of setup will work for you. You'll face a lot of slowdown if you find yourself working with 4K source, such as BMD RAW, though. Now, any old monitor will not do here. We still need a good monitor, and it needs to be accurate. If we just buy any old monitor and use it out of the box, then things are certain to go wrong. It's actually shocking how far off consumer end display tech usually is out of the box. So we need to do 2 things here. First, we need to choose a good GUI monitor, and this will be expensive, the good ones always are. And second, we need to calibrate it using a color checker or probe. So let's talk about good monitors for color grading first. Most consumer-end GUI monitors are LED or LCD. We are looking for an IPS panel LED monitor here if it's for dual use. We also need to take the gamut and bit depth into account as well. We're working for web with this setup, so we need the best possible coverage of sRGB or Rec 709 gamuts. And for bit depth, either 8 or 10 is fine. SDR web content is 8-bit, so we don't need to prioritize a 10-bit monitor for this unless we're working on very high-end projects. Now, to a certain degree, you can choose how much you want to spend. Good gaming monitors like the Asus ROG range can be a good starting point and produce reasonably good results with calibration, but there are more professional solutions available. BenQ has a range of professional monitors, and the PV270 is a good choice, but is 2.5K, which is an odd resolution since a lot of things nowadays are either 1080 or 4K. Another range to look at is the Asus ProArt monitor, which runs the gamut from 1080 to full 4K and mostly support 100% of sRGB gamuts as well. These Asus monitors come pre-calibrated, which buy you some time. But the thing about calibration is that it's an ongoing process, and we'll talk about that next. So, once we've chosen the monitor we want to grade with, the next step is to make sure that it is in fact accurate. To do this, we also need to use a calibrator. Now, these can be really expensive, and the high-end ones usually belong to people who carry out calibration services professionally. There are some good ones available to the consumer though. Datacolor Spider Pro is the most popular use for home professionals. It's a little device that sticks to the front of your screen and reads the light coming out of it and then makes adjustments based on those readings. These things aren't cheap, So alternatives could be the X-Rite Color Monkey and the X-Rite i1 Display Pro. These all work in broadly the same way, reading your monitor and adjusting based on those readings. When you are looking for a calibrator, you also need to check for compatibility with the monitor of your choice. Most of the time, the calibrator software will do the job, but sometimes there's built-in calibration tech for professional monitors, which may or may not cause some conflicts. And always double check and ask on forums, email the manufacturer's support department, whatever. Check this for consumer end monitors like the Asus ROG range as well. I once had an old Samsung E540 Rose, very good monitor, but did not cooperate with my color calibration unit, and I wound up having to kind of calibrate it by hand using the calibration unit as a kind of reference. Very weird. So you do need to watch out for that. Now, it's important to note that calibration is not a one-time thing here. Over time, all monitors drift away from the ideal color temperature and brightness, and many monitors develop uneven brightness as well. We need to calibrate our monitors every few weeks to ensure that we are retaining the color accuracy we need to deliver our work. Now, one final thing to mention. If you want to work across two screens, that's great. With a dual screen setup in Resolve, you only really see the graded video on the first monitor, so you don't need two ultra-expensive monitors for this. The second can be a generic GUI monitor, and that will not cause you any accuracy problems. So, this has been a good overview of choosing a GUI monitor to grade with. In the next lecture, we'll talk about choosing a dedicated external reference monitor and a DeckLink card to go with it. Click on through to the next lecture once you're ready. Now for the really expensive bit, external reference monitors and DeckLink cards. For this lecture, we're going to carry on as though we're building a 28 or 44 lane workstation with one or more graphics cards and a dedicated external reference monitor. Now, first things first, an external reference monitor does not just plug into your laptop or the back of your GPU like any other monitor. A reference monitor works by receiving a signal from a dedicated PCIe component in our machine called either a DeckLink card or a breakout card. We're just going to talk about Blackmagic DeckLink cards here, as they are the most cost-effective solutions. Bit depth is another factor here. The majority of DeckLink cards will support 10 bits of color, but they will have different limits to the chroma subsampling of the signal that passes through them. Remember that 422 effectively halves the colors we get. This will have some implications for the intended delivery destinations of our project, so we need to keep all of this in mind. There's really just one DeckLink card to consider if you're just working for broadcast and web and nothing is super high-end, and that is the Blackmagic DeckLink Mini Monitor 4K. These are relatively inexpensive and will support 4K material up to 30 FPS progressive in 10-bit and chroma subsampled to 422. This is suitable for broadcast and web work, though it may not be up to cinema. This card can give you a 4x4 signal that is unsubsampled, up to 12 bits at RGB when working at 1080 resolution up to a frame rate of 60 frames per second progressive as well. It is, however, limited to the Rec 709 gamut, so since it does not support P3 or Rec 2020, it is not the best pick for cinema deliveries. This is especially true since it's limited to YC BCR at 4K, which cuts our color resolution in half. If we're working with high-end projects or are delivering to cinema, then we need something a little more expensive. In fact, a great deal more expensive, sadly. The ideal DeckLink card for this kind of work is the DeckLink 8K Pro. Now, I know it says 8K, but this is the most cost-effective card for 4K P3 work as well. This card will handle pretty much anything all the way up to 8K 30 FPS progressive at 4x4 and in the Rec 2020 gamut, which makes it ideal for high-end ads, broadcast, web, and also projects going to cinema. Now that we've got our DeckLink card sorted, we'll talk about the kinds of monitors suitable for 4K and cinema work. These get super expensive very quickly, so don't be dismayed. It's possible to deliver to broadcast on the BenQ or Asus monitors mentioned in the previous lecture. These monitors are specifically for the high-end, and there is also a brand called Eizo as well, which is worth looking at, as they produce a range of self-calibrating monitors which are excellent choices for post-production freelancers. Once again, the following monitors really are the domain of full-blown post-production facilities and not really intended for individual freelancers. First, we have some brands that make OLED reference monitors. These are my personal favourite, as the contrast and colour quality on these monitors is incredible, and they give the best clarity by far, in my opinion. Now, these monitors cost anywhere from the equivalent of a few thousand to tens of thousands of dollars. First is Flanders Scientific. These monitors are an excellent choice and very common in the industry. Other brands include Sony's TriMaster range of monitors, and there's also Dolby, who produce a small range of reference monitors as well. Now, all of these can cost tens of thousands of dollars, and there's the upkeep to consider as well. Many of these monitors do not want to be exposed to UV light and should be kept in a light-proof room because of a special coating on the screen. Also, the color calibrators we mentioned in the previous lecture will not be enough either. They will need attention from a calibration professional at regular intervals to ensure they keep their color accuracy. When all is said and done, if you're a freelancer, you should stick to the likes of Asus ProArt or Aitzo monitors for mid to high-end ads and indie features. One of these, in conjunction with the Decklink 8K Pro, should see you in good stead. Now, there's something very important that we need to get absolutely clear here. Now, something we need to keep in mind here, there are three main kinds of connection to monitors. There's HDMI, DisplayPort, and there is SDI. We get the best quality of signal out of SDI, so do try and prioritize monitors with an SDI input if you're going to spend a lot of money on your Decklink card, okay? You need to be careful with monitoring on HDMI because sometimes HDMI can limit things to 422 or 420. You just want to make sure you are getting 4x4 through HDMI if you are connecting your monitor through HDMI. You need to check this. Like I said, you need to contact the manufacturer's support section or ask someone in a forum who's using the particular monitor you have your eye on, that kind of thing. It's really not worth buying something and then having it not work as you intended. So, we're almost at the end of this entire course now. We've got one more lecture to cover, and that's for control surfaces, and then we're done. So click on through to the next lecture when you're ready. Okay, this is the last lecture on workstation components, and it's about control surfaces. Now, these might seem like a nice to have, and it's true that their absence won't stop you from doing anything, but they can really speed up your workflow and allow you to carry out multiple complex processes simultaneously. We'll take a look at some. Now, these are mostly from the same company, as I've only ever used tangent control surfaces personally. First, we'll start with the cheapest solution. If you have an iPad or an Android tablet, and this isn't suitable for devices like the Kindle HD, you need a tab with some real performance behind it for this, then there's actually an app that lets you simulate and remotely control your grading software. It's called Element Versus, and there's a free version. This app gives you simulated grading controls on the screen of your smart tablet and allows you to use the primary wheels and make other more complex adjustments as well. This basically gives you a portable, digital solution for controlling your grading software at a fraction of the price of a real physical control surface, complete with macro keys, trackballs, and scroll wheels. The free version is basically a demo and allows you to use it for 1 hour every 24-hour period. The paid version is actually very cheap for what it is, and may well be the most realistic option for the majority of freelancers taking this course. This app communicates to your workstation via Wi-Fi. If your rig has no Wi-Fi capabilities, then this app will not work. Next, let's talk about the entry-level physical control surfaces. At the cheapest end, we have two, one from Tangent and one from Blackmagic themselves. The Tangent Ripple gives you the bare minimum, 3 trackballs, 3 dials, and some macro keys. By itself, it's not going to give you everything that you need, but the trick is to combine it with another piece of tech usually reserved for gaming. At home, I use a one-handed keyboard, a Razer Tartarus, and I've programmed all the keys on this to be commands for resolve. Combining this with a Tangent Ripple will give a very versatile and professional setup for a relatively low cost. After this, there's the Blackmagic Design Micro Panel. This features 3 trackballs and dials as well as knobs for most of the primary functions in Resolve, as well as a raft of pre-programmed keys for common tasks. It's a great panel to start on and can really streamline a lot of things, but you need to be aware of the fact that it will only function with Resolve. Its limited compatibility may not make it the best choice for everyone. Next are the mid-range options, and these are expensive but not insurmountable. The Tangent Wave 2 is an excellent control surface. I actually used a Tangent Wave 1 for years. The Tangent Wave 2 has all the trackballs, dials and knobs you'd expect, along with a host of fully programmable macro keys and an LCD screen that allows you to switch the functions of the knobs and dials as well. This surface gives you direct control over most functions in Resolve, and it's actually not that expensive for what it does. It also has excellent compatibility for other applications such as Final Cut, Premiere Pro and Avid. After this, there's the Blackmagic Mini, which is a step up and is also more expensive. It offers more keys and functions than the Wave, and also allows for some functions the Wave does not support, like the editing of curves, a task which typically requires the mouse. Again, this is a Resolve-only piece of kit, so spending a few $1,000s might not be the best idea if Resolve is only a part of your workflow. Now, after this, there are the panels which cost tens of thousands of dollars. Blackmagic makes one, and it's brilliant. I've used it in suites whilst working freelance, but it's not something anyone's going to be able to afford at home. So this has been a good overview of control surfaces for the freelance user. They're all expensive, so consider carefully how much mileage you will get out of these before splashing out on them. Right, that's the last lecture on building a workstation. If you want to go for this, then I cannot emphasize enough how important it is to check every single detail over and again. The last thing you want is a core that doesn't fit into your motherboard, or a deck link that cost you 3 times as much as you needed to spend, or a monitor that didn't have the right kind of SDI connection, or whatever. Think carefully about what most of your work really requires and build a specification to that. I would not advise building a rig speculatively, thinking you'll suddenly get a load of high-end work in simply because you own the machine. That doesn't work that way. Those contacts come slowly, those jobs come slowly, and it's going to take years if you've just started and haven't already established yourself to reach that point. So as always, the best way for you to do this is to start at your intended delivery destination and then work backwards. For example, I'm delivering web content with the occasional spot for broadcast. What do I need? A single GPU system with a DeckLink Monitor 4K Mini connected to a BenQ monitor set to monitor Gamma 2.4 should do it. You might not even need a 28-lane core if it's only occasional broadcast work you're doing. Alternatively, if I mainly deliver to mid-range broadcast and 4K high-end web content, what do I need? Since the only 4K here is for web, which is typically subsampled to 420 anyway, I can still get away with a mini monitor DeckLink, as it will allow for 4444 monitoring at 1080 HD for broadcast. For this though, maybe an Asus ProArt or ITZO monitor is a better bet. And if you grade mainstream features and high-end broadcast work, then you work out of a facility, so the selection and maintenance of the equipment is not your problem. Right, I hope you've gotten a great deal out of this course, and once you're ready, click on through to the final video of this course. Congratulations on making it this far.